Hello guys, my name's Ian Neil, and this week we're back with a lesson 10 in Paul McWhorter's Arduino with Python series. This week we've been passing some data from Python back to the Arduino. Now, what can I say? This week we have a lot of action going on. Most of the action, to be fair, is in the Arduino environment, and that's not because Python's doing nothing, it's because Python makes it so easy to do what we need to do. So let's get on with it. Let's have a quick look at some Arduino code. So if I change scene, here we go. So this is an important lesson this week. We are sending stuff from Python. Now, there's lots of ways we could do this. Just rattling off a few, we could have some code that just sits and waits for it. That's called blocking code, as in while the Arduino's sitting waiting, it's doing nothing else. Now, my Arduino's got lots of things to do. It's got some temperature sensors to read and things like that, so it can't be sitting doing nothing. So that method is rejected, totally rejected. We could also use a millis task. We've got a framework for that. We could hang something else off that. Or that could work, yep. It's a valid solution. In fact, other people I think have been doing the same sort of thing, having something in the main loop. We have another solution which could be in interrupts and stuff, but that's really, I thought that was far too complicated for such a simple request. So let's talk about a command that I discovered called serial event. Now, that is actually a command that is designed to do what we want. And if we jump right down to it, let's have a look at what it looks like. So, serial event. It's quite simple. You define a function called serial event, and it will be automatically ran after loop, but only if there's new serial data has been received. So, quite simply, you stick a function in called serial event, and the Arduino will take care of running it for you. All you have to do is get some data back from it, which is where we're talking about strings. Now, strings are an interesting thing in C. Don't really exist. They're an abstraction. They're really just a character array. And once we start talking of arrays in C, we have to start talking about pointers. Now, pointers can be quite troublesome. Now, I know I've had a few crashes with pointers, especially when you don't point to the right thing or you point past it. So first thing I did, considering I was going to be playing with pointers, is I decided to hang a heartbeat off my millis loop. So that's it. I have basically used LED number 13, the built-in LED, and I'm going to flash it. Turn it on for half a second, turn it off for half a second. It's just a millis job. I set it up with, let me see, where is it? There it is there. I defined the job cycle. I've set up a few variables for it in the loop. So we've got that, and it's just step and repeat for all the others. I've hung this off then. So every half second, the millis function will allow this loop, this if statement to happen, and it'll do something. It'll turn the LED, it'll toggle the status of the LED and thus turn it on or off. So that was simply so that I knew that my code hadn't hung. Anyway, back to these pointers. What's going on in serial event? Well, quite a lot as it happens. We have a buffer set up that's defined up top, and the buffer has a maximum size. So really all I'm doing is, if there's a character available and we are not flagged for a command as ready, as in we've already received one, but we haven't actioned it yet, which we will come to in a bit. Well, if there's a character available, we read it, and as long as it's not an end of line marker, in which case I'm using this \n, which is the new line character, or we haven't reached the end of the buffer, then we basically add it on to the command buffer and move the index pointer in that buffer along. Now, where does that index pointer point? Well, first run through, it points to 0, as in we are using the first character in the buffer. Notice it's a static. Whenever this function's called, it is not guaranteed it will have all the command ready. It's called faster than the PC actually sends to it. So this function gets called repeatedly, taking character by character or multiple characters on each loop, building the command into the index buffer as it goes along. Now, once it reaches the end of it, either the end of the command or the end of the buffer, then it slaps a null on the end of it to terminate the string, flags the command as true and ready, and resets that buffer index back to 0, ready for the next command. Now, this is the important bit here. That's being set for something in the main loop to notice. Okay, so let's think about what's in the main loop. Right, main loop, we've got our millis. You may have spotted earlier a job cycle 5 running every 10 milliseconds, which is where I basically have the main loop check to see whether there is a command ready, and if there is, it does something with it. Now, my commands are sent over from Python, quite simple. It's got a subject, equals, and then an action. So there's the subject will be a name. In my particular case, I've picked this as the name. Then the equals is like a delimiter, and then the action is what I want to do on the subject, as in what do I want to do with my BGR LEDs, which I have added on to my Arduino. I will show you that in a bit. So how do we then separate the subject, the delimiter, and the action? Well, that's where a quite magical C command comes in. It's called string toc, or string token, and what it does is you pass it the command buffer and the delimiters. The command buffer is defined up top, the delimiters are defined up top. What are they? Well, the command buffer is just a piece of space. In my case, it's 32 bytes plus 1 of space, and the delimiters, well, it's all these characters. So I can have my command and my action separated by any or all of these. I picked a bunch of them because they made sense to me. String toc takes that, and when it's searching for the subject, string toc takes the command buffer, the delimiters, and will return me a pointer to the subject, which in my case will be BGR LEDs, the word BGR LEDs. I then call it again, passing over the null. String toc's a clever command, it's re-entrant, so this null is telling it that it's looked in this before, and don't start from the start, start from the last pointer you handed back to me, the last delimiter, and then it gives me back another pointer. So effectively what I end up with is a command buffer and 2 pointers to different pieces of it, and those 2 pointers have finished with nulls that string toc has put in there. So effectively string toc has looked through my buffer, separated the pieces of it with nulls, and changed the command buffer. So the command buffer is altered by this. But either way, I end up with a subject and an action, and if my subject matches what I'm looking for, and my action does exist, as in there was one, the string toc didn't return a null itself to me, I've got an action. Now basically it comes in as a string, so I convert the string to an integer and then call this, which effectively turns on a blue, red or green LED as per the bit value of the number passed over. So if it's passed over a 0, all the LEDs are off. If it's passed over a 1, the blue LED is lit. If it's passed over a 2, the green. If it's passed over a 4, the red. If it's passed over, for example, 3, that would be bits 0 and 1, so the blue and the green LEDs would be lit. But as it happens in my Python code, I'm not using that. I'm just passing over 1, 2 or 4 to light up blue, green or red. Now let's have a quick look at other bits and bobs in this code that are essential. I've got some LEDs defined and built in this, so I've had to define their numbers here. I've put the blue, green and red LEDs on pins 5, 6 and 7. I'm using the heartbeat LED, that's 13 in my Nano, it's 13 on the Arduino, but I'm just using this so that I pick it up. This is a built-in variable to Arduino. I'm setting up my job cycles. I've got my buffering and command stuff there. I then make my LEDs all be outputs, and then I'm setting up these timers and things. I've got this in here for the heartbeat, and I basically added on 2 tasks to my Millis loop, the action commands and the heartbeat. So that's pretty much the Arduino code looked at. Let's have a think about what these LEDs look like. Now, LEDs are quite simple. My circuit, I've got 3 of them, and 3 current limiting resistors, and one of the positive of one of each of the LEDs goes to the pin. The negative leg, the as it happens in the LEDs, the shorter leg goes to a resistor, which then goes to earth or ground. And I'm using 470 ohm resistors because I happen to have them in the box. But 330s will do. Something around about that will be fine for the Arduino. So let's have a quick look at the Python code. The Python code that sends all this information over, or rather one command with a number. And if we look at that, and I make it so that you can see it, there we go. Right, so it really all happens here. This is the Python code. It works out whether I need to update, puts that in a variable. Now I will look at this function in a moment. It's quite simple. I pass it over the temperature of the DHT11 that happens, and it works out whether I'm going to be lighting up the blue, green or red LEDs, and that will be whether the temperature is below 5, I think it was, below 5 degrees. Yes, there it is there. If it's below 5 degrees, the blue LED. If it's between 5 and 30, the green LED. And if it's above 30, it's too hot for Ian, so it's the red LED. And what this little bit of cleverness is doing is it's checking to see whether the value's changed since the last time. The temperature isn't going to change an awful lot or very quickly, so I don't need to send something that hasn't changed, so it only sends over a command, an update command to the Arduino if indeed something has changed. And this is the construction of the command. It's quite simple. It's using the % operator to build the string, so it literally sends over those characters followed by the number %d, the number that came from that variable which was filled by this function, which we will look at in a moment. And then it simply writes that out. It has to encode it first. Still have to understand exactly what it encodes it as, but it writes it out, and then this sets the variable so that it knows next time around whether it needs to action again. And that's, if we have a quick look at that, you shall see that's a very simple function that basically works out whether to send 1, 2 or 4 depending upon where you are, higher, in between or lower than the thresholds that as it happens I'm not sending them because I'm just relying on the defaults of the function. Now, one other thing I should let you know about in this code, I've changed the meter type. I've added a BGR tricolored LED into it, so it's one LED can be blue, red or green, and I've added that in there, and I've created new classes for some new LEDs. So let's have a look at that. There's the small LED we had last week, the LED bank, which you'll see in a moment, and then this is the BGR LED. This is one single LED that can be blue, red or green. I actually also made a tricolor LED which can accept RGB values. I haven't actually found a use for it yet, but the code's there. If I do eventually find a use for it, I've got a BGR LED. So let's have a quick look at this in action. So let's look at some hardware demoed for you. So there we go. That's it in all its loveliness. We've got Mr. Blue, Mr. White, we've got the pot, we've got 3 LEDs there, although they're very difficult to see on this screen actually. Yeah, you got 3 LEDs there. The green one's lit up, and you can see the flashing light there. That's the heartbeat at work, showing me that my code is actually running. So quite simple, 3 LEDs added on with 3 resistors and using the built-in. And if I show you what it looks like in the browser, there we have it. So I can move that around if it would update. Let me give this the focus. There we go. There we go. So it'll update around. And we see the blue, green LED, or red LEDs here. They're the ones that are reflected in the hardware in the real world. This is the new LED that I've added in for. It's actually doing a bit of threshold work here. So if this voltage is greater than 70%, it should turn red. And if it's less than 30%, which is 1.5 volts, it should turn blue, just like that. That's working perfectly, albeit with a wee bit of lag, as my machine seems to be struggling again. Can't really test the temperature one because, well, it's quite pleasant in my room at the minute. So there we go. Main takeaways from this week's lesson. Check out the serial event command in Arduino and the string talk function. I was, quite frankly, amazed with them. They did all the hard work for me. Yes, I had to do a wee bit of pointer work, but that's not too difficult. If you need pointer refreshers, there is a ton of stuff on the internet. I ended up not even having to use pointer arithmetic or anything. I just used the square brackets and indexing, and that worked best for me because I had a size of buffer that I was defining, and I wanted to check that whether it exceeded it at the same time as using the same number. So that made more sense for me. Other than that, that's me. Everything will be on GitHub as usual, and have a great day. Thank you.